When working with compound interest, we've already seen that we can change the number of periods that the interest is compounded per year. But what we haven't talked about is how changing those number of periods changes the rate that you are actually earning throughout that year. So we have an APR of say 4%, but the number of times that we compound per year is going to affect how much we actually earn. So the annual percentage yield, or the APY, is going to be determined based not only on the interest rate, or the APR, per year, but also the number of periods in which that interest is compounded. So to find the annual percentage yield, or the APY, we're going to use the formula of 1 plus R, where R is your rate in decimal form, divided by N, where N still represents the number of compounding periods per year, to the N power minus 1, and then times 100%. And the times 100% is just going to change our APY back into a percentage. So in this example, we want to determine the annual percentage yield for an account paying 4% interest compounded quarterly. So our APY is going to be equal to 1 plus, our R in this case is 4%, so as a decimal, 0.04. Our N value, we're compounding quarterly, so our N value will be 4 as well, minus 1 times 100%. So we're going to plug this into our calculator, and we get that our APY is equal to 0.04060401 times 100%. So our APY, rounded to the nearest hundredth of a percent, or to 2 decimal places, would be 4.06%. So if we have an APR, an annual interest rate of 4% compounded quarterly, our APY, our yield, will actually be 4.06%. So let's look at another example. In this case, we want to determine the APY for an account paying 7% interest compounded monthly. So we have an APY equal to 1 plus R over N to the N power minus 1 times 100%. So our APY in this case is going to be 1 plus 0.07 divided by, in this case, we are compounding monthly, so our N value would be 12. So to the nearest hundredth of a percent, or to the nearest 2 decimal places, we have an APY of 7.23%. So notice that if we were compounding the interest annually, only one time per year, our APY would be 7%. What we would be yielding is only 7%. But because we are compounding more than once per year, in this case 12 times per year, what we end up with is actually an APY we're yielding 7.23%. So you can see there's a distinct advantage to having compounding periods occurring more often. So a compounding period of monthly is going to produce a higher APY than a compounding period of annually.